black holes are notoriously difficult to observe. They're aptly named black for a reason. Even though light travels at the universe's fastest speed, it can't escape a black hole's gravitational grip once it gets too close. However, not all black holes are enveloped in darkness. Some even outshine entire galaxies. In fact, there exists a black hole the size of an entire solar system that powers the brightest known object in the universe. This object is what astronomers refer to as a quasar. Quasars are a type of active galactic nucleus, essentially the core of a galaxy housing not just any supermassive black hole, but one that is actively consuming large amounts of gas, dust, and more, even if it means tearing a whole star apart. Astronomers determine whether a black hole is active by examining its brightness, or more precisely, the brightness of the material swirling around it. As matter spirals closer to the black hole, it heats up. When things get hot, they emit light. Some of this light is directed straight into telescopes, while some is absorbed by additional matter further from the black hole, causing it to heat up and glow as well. Overall, an active galactic nucleus emits light across the entire electromagnetic spectrum. A general guideline is that if a galactic core is 100 times brighter than the rest of the galaxy combined, it is considered an active galaxy with an active galactic nucleus. Astronomers are particularly fond of these objects, largely because of their brightness, or more accurately, their luminosity. Although the terms sound similar, they have different meanings. Luminosity refers to the amount of energy an object emits, while brightness describes how bright the object appears to an observer based on its distance. Space is vast, so an active galaxy might be far more luminous than an average galaxy, but not appear brighter in images because it is much further away. Nevertheless, astronomers have methods to report brightness that attempt to account for varying distances, and it is simpler to refer to them as bright rather than luminous. Therefore, the term bright will be used. The fact that active galactic nuclei like quasars are significantly brighter than non-active galaxies makes them easier to detect, especially when observing distant regions where signals become increasingly faint. This is why almost all galaxies claiming the title of most distant galaxy are quasars. Together, these quasars assist astronomers in understanding the universe's early years. However, visibility doesn't equate to understanding. For instance, the rapid growth of quasars remains a mystery, necessitating further study. The challenge is that even though quasars are often the brightest objects in their cosmic neighborhoods, they can be surprisingly difficult to locate. This is primarily because they don't resemble massive galactic cores and often appear as ordinary stars. In fact, the term quasar is short for quasi-stellar radio sources. Nonetheless, distinguishing quasars from stars is possible, though it requires more effort. Enter SMSS J052915, dated 43515.2.0. It is the brightest quasar ever recorded. This record-breaking quasar was initially spotted by a telescope survey mission in the 1980s, but astronomers didn't recognize it as a quasar until 2023. This delay was likely due to an algorithm astronomers used to sift through the vast amounts of data the telescope collected nightly. In other words, the survey lacked a specific target and was instead observing a broad section of the sky containing various potentially interesting objects. Astronomers depend on software to filter out irrelevant data. The computer probably dismissed SMSS J05291580435152.0, thinking, "This can't be a quasar, it's too bright. It must be a foreground star, so don't bother." However, thanks to a second observation with a different telescope, a team of astronomers was able to reveal its true identity. It wasn't a random star in the Milky Way photobombing the image, but a quasar located at a redshift of 3.962. For those unfamiliar with the term, redshift indicates how far away other galaxies are, especially those that are extremely distant. Redshift can be likened to the Doppler effect for light instead of sound. If an object like a galaxy is moving away, the light waves stretch, making them appear redder. As the universe is expanding, and the expansion is accelerating, the further a galaxy is, the more its light is redshifted, resulting in a higher redshift number. So if astronomers measured a redshift of 3.962 for this quasar, how distant is it? And considering that light takes time to travel across the universe, how old is the image we have of this quasar? The exact answers remain uncertain. Converting redshift to light years requires assumptions about the universe's expansion rate, which astronomers still debate. However, roughly speaking, this quasar is seen as it was about 12.8 billion years ago, when the universe was approximately 860 million years old. This places it much closer to us compared to other exceptionally large quasars. Given this distance, the quasar appears dim in the sky, but is actually about 500 trillion times more luminous than the Sun. No other known object in the universe emits such brightness. To produce all that light, it requires an active supermassive black hole, approximately 17 billion times the mass of the Sun. While not the most massive black hole ever discovered, it is still impressive. It also appears to be the fastest growing black hole in the universe, consuming between 280 to 490 solar masses worth of matter each year. Averaging this out, it consumes about one sun's mass per day. This likely means it is feeding off the largest known accretion disk in the universe, if the accretion disk is likened to a plate. These are a lot of superlatives. Astronomers may eventually discover an even brighter object, perhaps another misidentified quasar lurking in survey data. In the meantime, they continue to investigate how these quasars are formed in the first place. Thus, the future of quasar research appears to be quite luminous. In other words, bright. As fascinating as quasars are, their influence extends far beyond their dazzling light. These cosmic powerhouses play a crucial role in shaping the galaxies that host them. When a quasar is active, the immense energy it releases can regulate star formation within its galaxy. This process, known as feedback, can either trigger the birth of new stars by compressing surrounding gas, or suppress it by blowing the gas away, effectively halting star formation. This delicate balance is essential for the evolution of galaxies, ensuring they don't become too dense or too sparse over time. But how exactly do quasars generate such immense energy? At the heart of every quasar lies a supermassive black hole, millions to billions of times the mass of our Sun. Surrounding this black hole is an accretion disk, a swirling, spiraling disk of gas, dust, and other cosmic debris. As matter spirals inward, gravitational forces heat the material to extreme temperatures, causing it to emit vast amounts of electromagnetic radiation across the spectrum, from radio waves to X-rays. This process is incredibly efficient, converting a significant portion of the black hole's mass into energy, which is why quasars shine so brightly. In addition to the accretion disk, many quasars also produce relativistic jets, narrow beams of charged particles that are ejected at nearly the speed of light. These jets can extend thousands of light years into space, impacting the intergalactic medium, and sometimes even influencing the formation of nearby galaxies. The exact mechanism behind jet formation is still a topic of active research, but it's believed to involve the interplay between the black hole's magnetic fields and the angular momentum of the accreting material. Understanding quasars also provides invaluable insights into the early universe. Since quasars are so luminous, they can be observed across vast distances, allowing astronomers to peer back in time to when the universe was just a fraction of its current age. By studying quasars at different redshifts, scientists can trace the growth of supermassive black holes and the evolution of their host galaxies over billions of years. This historical perspective helps us piece together the complex puzzle of cosmic history, revealing how the large-scale structures we see today came to be. One of the most intriguing questions about quasars is how these supermassive black holes grew so rapidly in the early universe. Given that the universe was only a few 100 million years old when the first quasars appeared, the black holes powering them must have formed and accumulated mass at an astonishing rate. Several theories have been proposed to explain this rapid growth, including the direct collapse of massive gas clouds, the merging of smaller black holes, and the presence of dense environments that facilitate the swift accretion of matter. Ongoing observations and simulations continue to shed light on this cosmic conundrum, bringing us closer to understanding the true nature of these enigmatic objects. Looking to the future, advancements in telescope technology and data analysis techniques promise to revolutionize our study of quasars. Next-generation observatories, both ground-based and space-based, will provide unprecedented resolution and sensitivity, enabling the detection of even fainter and more distant quasars. Additionally, breakthroughs in artificial intelligence and machine learning are enhancing our ability to sift through massive datasets, uncovering quasars that might have previously been overlooked. These technological strides will not only increase the number of known quasars, but also deepen our understanding of their diverse properties and behaviors. Moreover, the interplay between quasars and other cosmic phenomena offers exciting avenues for exploration. For instance, the relationship between quasars and dark matter, the elusive substance that makes up most of the universe's mass, remains largely mysterious. Some theories suggest that dark matter halos could influence the formation and evolution of quasars, while others propose that quasars themselves might play a role in shaping the distribution of dark matter in their vicinity. Investigating these connections could provide critical clues about the fundamental nature of the universe. As we continue to unravel the mysteries of quasars, one thing remains clear. These extraordinary objects are not just bright spots in the night sky, but key players in the grand narrative of the cosmos. They serve as beacons that illuminate the vast distances of space, guiding us in our quest to understand the universe's origins, its evolution, and its ultimate fate. Whether you're an aspiring astronomer, a curious enthusiast, or simply someone captivated by the wonders of the night sky, the study of quasars offers a glimpse into the most powerful and dynamic processes at work in our universe. So, the next time you gaze up at the stars, remember that among those countless points of light, there are some that harbor the secrets of quasars, silent giants whose brilliance continues to inspire and challenge our understanding of the cosmos. Stay tuned as we delve deeper into these celestial phenomena, exploring the forces that bind galaxies together and the mysteries that quasars hold. The journey through space and time is just beginning, and who knows what other marvels await our discovery.